So yesterday we went over the naming rules for molecular compounds. Okay, we also went over the naming rules for ionic compounds that have multivalent metals. We went over the naming rules for ionic compounds that have polyatomic ions in them. And judging from the quiz today, the thing that gives us difficulty is deciding which kind of compound we're looking at so that we know what rules need to be applied. Okay, and that's kind of what I thought would give us trouble. That's why I had this plan for right after the quiz. Okay, so what we have here is a list of several different compounds. Some of them are ionic. Some of them are molecular. Some of them have multivalent metals and their names would require Roman numerals. Some of them have polyatomic ions. But they all need to get named. Okay, so here's some things that we need to remember. How can I tell if something is ionic? What will it have in it for sure?
Metal and a non-metal.
A metal and a non-metal. Okay. In fact, it'll for sure just have a metal. Okay. Our molecular compounds do not have metals in them. So if you have something that has a metal in it, it's definitely an ionic compound. Okay. So if we're looking at these, the first thing I should look at is there a metal? If there is, it's ionic, and I need to name it like an ionic compound, which means I don't use prefixes. Okay? If it's two nonmetals, then I do have to use prefixes. Okay? If it's got a polyatomic ion in it, then because it has an ion in it, it would be an ionic compound. Okay? Follow the ionic naming rules. Right? So that's the challenge with these 15 compounds. Decide, is this ionic or molecular, and then apply the correct naming rules to it. Okay, so I'm going to give you about 5 minutes, and then I'll go through the first, like 6. Okay, then I'll give you another 5 minutes or so. We'll go through another 6 or so, something like that. Okay. How do you know if you need to use a Roman numeral? What will it look like on your periodic table? The metal will have
Two possible charges.
2 possible charges. Okay, so always look for that. If you're looking at a metal that has more than 1 possible charge, then you have to use a Roman numeral. Okay, so make sure you're always looking at your periodic table, okay, when you're writing out the names. All right, let's look at the first 5 here, at least. Okay, so for question number 1, I've got lithium and chlorine. Is lithium a metal? Okay, so this is an ionic compound, then I need to name it as such. All right, do I use prefixes? No. All right, so this stuff is just going to be then lithium chloride. Okay, questions on that one? All right. Second one, I have chromium and fluorine. Is chromium a metal? It is. Okay. Does chromium have more than 1 possible charge? Yes. It could be a 2 or a 3. So I have an ionic compound, and it's going to need a Roman numeral in its name. Okay, so we've got chromium, fluoride. Okay, and now I need to figure out what the charge on chromium will be. Charge on fluorine is always -1. So how many negative charges are there? 3 times -1 is -3. Okay, there's only 1 chromium here, so to get 3 positives, the charge on that chromium must be 3 plus. 1, 2, 3. Okay, so the point I'm trying to make here, guys, is that when we were doing this before, you guys were great at it. Okay, you're doing it no problem, but it's because you knew every single one needed to have this set of steps used on it. Okay, it's a little trickier when you don't have that laid out for you and you have to decide, oh, does this one need Roman numerals? Does this one need prefixes? That's a little bit more challenging. Okay, that's why we're doing this today, so that we get the hang of how to make that judgment call on what kind of compound is it and what do I need to do. Okay, that's a bit more challenging. All right, so for number 3, okay, I've got phosphorus and bromine. Are there any metals in that compound? No, so this is a molecular compound. Okay, so I'm going to go phosphorus, okay, tribromide. Okay, named it as a molecular compound. Okay, and then for number 4, I have zinc and iodine. Are either of those a metal? Yes, zinc is a metal. Okay, does zinc have more than one possible charge? No, it can only be a +2. So will I need Roman numerals for this one? No. All right, so then I can just name it like an ionic compound. Zinc iodide. All right, and then number 5, I have silicon and oxygen. Either of those a metal? No. So this is what kind of compound? It's molecular. Okay, so this will be silicon dioxide. Okay, so those are the questions you have to ask yourself. Okay, like every time I do one of these, those are the questions I ask myself in my head. I just ask them out loud so you can hear them. Okay, but I look at it and go, okay, is there a metal? Okay, then it's an ionic compound. Does it need a Roman numeral? No. Okay, then I know what to do. Okay, or yes, it does need a Roman numeral. Then I know what to do. Okay, ask yourself those questions each time you encounter one of these, and you'll get them right. Okay, give you a little bit more time, and I'll go through another 5 here in a minute or two. Okay, let's have a look at the rest of these here. So for number 11, I've got nitrogen and oxygen. Is that an ionic compound or a molecular compound? It's molecular. They're both non-metals, right? They're both on the right-hand side of the staircase. All right, so I'm going to name this one nitrogen monoxide. Okay, got to use a prefix on the second one, but we don't use mono on the first. Okay. All right, number 12, I've got beryllium and I've got a polyatomic ion. Okay, so this is an ionic compound, and I'll name it as such. This will be beryllium, and Cn is cyanide. Okay, and then number 13, very similar, except instead of beryllium, it's going to be barium. Okay, number 14. What kind of compound is that? Does it have a metal in it? Yeah, it does. Okay, if it has a metal in it, it's ionic. It also has a polyatomic ion in it, HCO3. Okay, is hydrogen carbonate, or sometimes bicarbonate. Okay, so this stuff is sodium hydrogen carbonate. It has a more common name. You've probably used it many times in your life. It's baking soda. Sodium hydrogen carbonate is baking soda. Okay. All right, and then number 15. I've got 2 nonmetals. Okay, this does actually look like a polyatomic ion. It also looks like phosphate. Okay, but when it's not attached to something, we would name it like a molecular compound. This will be phosphorus tetraoxide. Okay, now I was not trying to like humble you or take you down a peg or anything like that. Okay, I know you were probably feeling pretty good about how well you could name things the other day. Okay, and you'll get back to that. Right, it's just a little bit tougher when we've got all the different situations for naming all in one place, and we have to decide which naming rules to use. That's where that skill becomes more important. Right? Okay, if we're going the other way, so what we've been doing so far is mostly just turning the formulas into names. Okay, we also have to be able to go the other way, and that is turn the names into formulas. Right? And we've already kind of talked about how to do that. With an ionic compound, what do I have to do to make sure I get the right numbers? Okay, what do I do with the charges on the metals and the nonmetals? Drop and swap. Okay, so if I have an ionic compound, okay, it has a metal in it, I write the charges, I drop and swap them, I get my new formula. Okay, if I have a molecular compound, how do I know what numbers to use? What will be in the name to tell me what numbers to use?
The prefix.
The prefixes. Okay, the prefixes will tell me what numbers to put. All right, so if I have a, sorry, those are just the steps here, so quickly skip over those. All right, so if I'm looking at this first one here, where I have calcium phosphide, okay, is that going to be an ionic compound or a molecular compound? It's ionic. Calcium is a metal, right? So when I'm writing the formulas for ionic compounds, okay, I go metal and I write its charge. Okay, so calcium is always a 2+. I can look that up on my periodic table. Okay, then I look up phosphorus and I write its formula, P, and its charge, -3. Okay, and now to get the formula, I drop and swap those numbers. Okay, so I take the 3, I drop it, and I put it over here on calcium. I take the 2, I drop it, I put it over here on phosphorus. Okay, now I have my correct formula. Are you okay with that? Okay. When we do the drop and swap, what that allows us to do is make sure that all the positives and all the negatives add up to. Okay, I mean, if you look at this now, I've got 3 calciums, each one with a 2+ charge, for a total of 6 positives. I've got 2 phosphorus, each one with a -3 charge, to give me 6 negatives. The drop and swap just makes sure that I get those charges to balance each and every time. Okay? Now, there's a couple of odd cases that we have to be aware of, okay, with the drop and swap, where the initial drop and swap is not the last step. Okay? And that would be in a situation like this. Okay, if I have manganese 4 sulfide, so this is actually going to allow us to practice 2 things. Okay, I want to write the formula for this compound. So the first thing I do is I write the formula for manganese, which is Mn. What charge does manganese have in this compound? 4. That's what the Roman numeral tells me. Okay, the Roman numeral is there to tell me this is the manganese with the 4+ charge. Okay, it doesn't tell me there's 4 manganese. It tells me use the 4+ in the drop and swap. All right, and the other thing I have in there is sulfide. Sulfide's charge is -2. When I drop and swap this, I get 2 and 4. Okay, should I leave it that way? I should not. Okay? When you can, with ionic compounds, you want to put them in their lowest terms, just like a fraction. Okay? You wouldn't leave 2/4 as a fraction. You reduce that to 1/2. Okay? And you would do the same thing here. So this will be MnS2. Okay? It doesn't come up very often, but it comes up once in a while. We just need to be ready for it. Okay? Like number 3, where it's not manganese sulfide, but it's manganese 4 oxide instead. So it'd be very similar to what we just did there. Okay, let's have a look at cesium oxide here, number 2. Okay, so formula for cesium is Cs. What's cesium's charge? Bottom left corner. +1. Okay. And it is with oxygen. Oxygen is always a -2. So drop and swap. The 2 comes here. The 1 goes there, but we don't write 1s. CS2O.
When we drop and swap, can we get rid of the negative?
Yes. Yeah. Otherwise, you'd be saying, like, I have less than nothing of this stuff. Right? I can't have -2 cesium atoms. So yeah, the negative and the positive come off, and we just use their absolute values. Okay, I'm going to have you guys try, let's say 3 through 10 for right now, okay, and then we'll go over those. Okay, so 3 through 10 for right now, and then we'll walk through those together in a couple minutes. All right, so we're starting with number 3 here. Okay, we have manganese 4 oxide. Manganese is a metal, okay, and it has a Roman numeral. So I'm going to write Mn, okay, The Roman numeral is 4, which tells me use the 4 plus charge when you do your drop and swap, and it's with oxygen, which is a -2. All right? When I do my drop and swap, I would get 2 and 4, which I can reduce to 1 and 2. Okay, so that's what I'd be looking at there, MnO2 for that one. Okay, questions on that one? For number 4, I've got iron 2 sulfide. So again, an ionic compound, a metal that has a Roman numeral. Okay, the Roman numeral is there to tell me what charge to put on iron for the drop and swap. Okay, so this is the Fe with the 2 plus charge. It's with sulfur, which is always a -2. Okay, what do those two things already do? They already add up to 0. There's my formula. Okay, the other way you could do that is you could drop and swap, and you'd end up with 2 and 2, which you can reduce to, 1 and 1. Actually, not 0 and 0, but 1 and 1. Okay. All right, number 5. We actually just had this one on going the other way. Okay, I gave you the formula and asked you to come up with the name. Okay, potassium permanganate. So potassium is K, and it has a +1 charge. Permanganate is a polyatomic ion, MnO4, and it has a -1 charge. So are these things already balanced? They are. There's my formula for the little purple crystals that stain your skin. Okay. All right, number 6. I've got silver chloride. Okay, silver is a metal. Okay, so I'm going to have to drop and swap. This is an ionic compound. Okay, silver's formula is Ag. Okay, chlorine's formula is Cl. Silver's a +1. Chlorine's a -1. So is this compound okay the way it's written? It's done. Okay, for number 7, I've got copper 2 hydroxide. Okay, what have I not had so far at all? I haven't had a molecular compound yet. Okay, in fact, there aren't any until you get to like number 15, I think is the first one. Okay, that's the first molecular compound, it's all the way down there. All right, so we've got copper 2 hydroxide. So the formula for copper is Cu. The Roman numeral tells me it's a 2 plus charge. Okay, hydroxide is a polyatomic ion, OH, and its charge is -1. What am I going to have to do here that I haven't had to do yet? I'm going to have to use brackets. Okay, because when I drop and swap, the 1's going to come here and the 2's going to go here. But if I write it that way, that doesn't mean 2 hydroxides, it means 2 hydrogens. Okay, I need to enclose my polyatomic ion in brackets if I'm putting a number beside it. Okay, so a very common mistake there would be to forget the brackets. All right, number 8, ammonium sulphide. Now this one's a bit tricky. Ammonium is a polyatomic ion, but it's the only one on your chart that's positively charged. Yep, things that are positively charged generally behave as metals or nonmetals. Metals, yeah. If you look on your periodic table, all your metals are positively charged. So ammonium, okay, actually acts like a metal. Okay, so it's NH4 and it has a charge of +1. Okay, it's with sulfur, which has a charge of -2. So when I drop and swap, the 1 will go over to sulfur, the 2 will come here. So what am I going to have to put around ammonium? Brackets. Okay, that's where that 2 goes. Okay, no different than if it was sodium sulfide. You put a 2 next to the sodium. All right, looking at number 9, we've got nickel 2 bromide. Okay, so again, an ionic compound. The Roman numeral tells me what charge to use. So I'm going to have Ni with the 2 plus charge. Okay, bromine, okay, is a -1. So when I drop and swap, okay, the 1 will come here and the 2 will go there. That's my formula for nickel 2 bromide. Okay, and then number 10, we've got iron 2 oxide. Okay, so that's an ionic compound because iron's a metal. The Roman numeral tells me it's a 2+ charge. Oxygen is always a -2 charge. So does that compound already work out that way? Okay, that's the way it looks. Okay, let's have a look at 15, just because we haven't had a single molecular one yet. Okay, how do I know 15 is molecular? Okay, it's 2 nonmetals, and what does it have in the name? Prefixes. Okay, either one of those is a sign that this is a molecular compound. I don't have to drop and swap a molecular compound because the prefixes tell me what numbers to use. Okay, so this is phosphorus and oxygen. Okay, di means how many? 2. Penta means how many? 5. Okay, so those ones are easy. Okay, don't have to do any dropping and swapping, nothing. You just read the prefixes and put the numbers on. Okay. All right, let's have you guys keep going on this. But here's the thing: you don't have to copy these down. These are actually in your digital workbook. Okay, so I'll call that up and put it up on the board. And this morning, I put the keys to these on Google Classroom. All right, so if we go to okay, so the keys to all the naming worksheets in your workbook are posted here. Right? You're currently working on the one that's called naming worksheet and key number 3. So this one here. Okay, the one that's darker for some reason. Okay, so that's the key. Right? You can find the actual worksheet itself. Okay, in the course materials. Okay, and it's unit 1. And it's on page. That's right here, it's this one here. Okay, so it's the bottom of page 2 and the start of page 3. Those are the ones we're working on right now. All right, so if you want to have them next to you, like in front of you on your phone, that's fine. Okay, but here's the thing, guys. I put the keys up there for a reason. Okay, and that reason is not for you to go, oh, I'll have this done in no time. I'll just copy the answers because you won't get anything out of that. Okay, the idea here is that you check your work as you go. Do no more than 5 before checking the key. Okay? The worst thing you could do is do 20, look at the key and realize, I just practiced doing this wrong 20 times and now I'm really good at it. Okay? So do like 5, check if you're doing them right. If there's one that you didn't get right, okay, then either ask for help if you can't figure out why, okay, and I'll come over and I'll help you out with it. Right? But we're going to be working on that for a while here. I'll give you a break in a little bit. Okay? Or maybe I'll give you a 2-minute break right now. We've been working pretty steady. So I'll give you a 2-minute break, and then we're going to come back to these questions here.